Hello and welcome to this Open Automation Software Builder Series episode on how to implement alarm escalations over time. In many cases we trigger alarms based on value thresholds. In other words, if a particular value such as a voltage drops below a configured threshold, then this would trigger an alarm. These types of alarms are based directly on the value of a signal, and in OAS would be configured using high or low thresholds on a tag value. However, what if we have a digital input and we want to generate alarms if that digital input stays true for too long? Or how do we escalate the alarm the longer that digital input stays on? The basic requirements are that for each escalation level, we want a different alarm message, alarm group, and delay. As the alarm moves through the escalation levels, each previous level should automatically be cleared and acknowledged so that only the current escalation level remains active. Let's have a look at this visually. At first, the digital input state is false. Let's call this the idle state. At a particular point in time, this digital input will become true. Let's call this the running state. Now let's say this input represents some kind of machine that's only supposed to run for a given amount of time, otherwise it should trigger an alarm. This first alarm, let's call this the warning state, and for the purposes of this video, we'll make it 10 seconds so that we don't have to wait too long. Now if the machine stops, the warning alarm should clear, but remain on the screen. However, if the machine keeps running, then we want to have another escalation level. So let's call this one the urgent level, and it should be triggered 10 seconds after the previous state, and the warning alarm should be cleared and acknowledged. Only the urgent alarm should remain on the screen. Again, if the machine stops, the urgent alarm should clear but remain on the screen. Let's introduce one more level. Let's call this the critical alarm. It should be triggered another 10 seconds after the urgent alarm, and as before, the critical alarm should supersede the urgent alarm by clearing and acknowledging it. Before we dig into the implementation, I want to quickly summarize the OAS alarm logging and notification features. All of the features you see here in red are enabled in the alarms.net or web alarms products, depending on whether you are building solutions for desktop or web applications. The first step is to configure alarm thresholds on the tags where you want to trigger an alarm if that threshold is exceeded. OAS provides 6 alarm types: the digital threshold, which is true or false, 2 low-level thresholds, 2 high-level thresholds, and 1 rate of change threshold. With the low and high thresholds, you can configure OAS to automatically clear and acknowledge a low alarm if, say, a low-low alarm occurs. Same with the high alarm. This depends on whether you want both or just one to be active at any time. The great thing here is that you can configure alarms for any of your tags, no matter what the data source. This can be a calculation, another tag, or one of the many supported data sources. Once you've configured the thresholds, the next step is to create notification groups if you want to send notifications, and logging groups if you want to log alarms to a database or a CSV file. An alarm notification group or an alarm logging group is essentially like a filter. The alarm logging group, for example, will only log an alarm when it occurs and if it also matches the parameters of the filter, such as priority, state, the group, and so on. The same applies to the notification group. This means you can create as many logging and notification groups as you need. Let's create an alarm logging group so we can log our alarms to a database and then view the history later in the video. To configure an alarm logging group, I've opened the OAS Configure application. I'm going to go to Configure, Alarm Logging. In here, we can create a logging group name such as Machine Alarms, and we're going to make sure logging is active. In the Filters tab, this is where we tell the logging group which alarms should be logged based on various parameters such as the state, the priority, the type of alarm, and the type of alarm threshold. We're going to leave this as defaults so that it logs pretty much every alarm except communication and tag client failures, which we're not using in this video. In the nodes, I'm going to add the localhost node, which is my current computer running the OAS engine. I'm going to log to databases, although you can also log to CSV here by enabling this. Today we're just going to log to a database. I'm going to choose a MySQL database that I have on a server. I'm going to set the IP address, and then we're going to set up the database name, which in my case is OAS. The table will be alarms. The username is also OAS, and then I'm going to paste the password in here. I'm also going to make sure we only log one record per alarm. This ensures that every unique alarm is a single row rather than every single alarm state change being logged as a separate row. And that's it. We can now add this group, and there we have it. So now that we've added the logging group, any alarms should now be logged to a database. Let's have a look at one solution. This first solution will use the time on and counts feature of the digital input to track how long the digital input has been true in number of seconds. We can then use a calculation tag to generate the state as an integer and use the low, high, and high thresholds to create 3 different alarm levels. For example, we'll make the warning state a low threshold with a value of -1. The urgent state will be a high threshold with a value of 1, and the critical state will be a high threshold with a value of 2. There's one problem here though. We can configure OAS to automatically clear the urgent alarm when the critical alarm occurs, but the warning alarm will stay on the screen because a high alarm cannot clear a low alarm. To fix this, we need to introduce another tag to handle the acknowledgement of the warning state. This can be done using the acknowledge alarms feature, which is when a particular tag goes true, it will acknowledge the configured groups. So the data source of this tag will be the high alarm active state, which is the urgent alarm, and when this is true, it will trigger the acknowledgement of the warning alarm group. Let's visualize this. Here we have the digital input called DI, which is a Boolean data type, and it's got the enable time on and count set to true with the units of seconds. Then we have an alarm level tag where the calculation is shown at the bottom. This logic says that if the digital input is true, then after 10 seconds, set the state to -1. After another 10 seconds, which is 20 seconds, set it to 1, and after another 10 seconds, which is then 30 seconds, set it to 2. So this alarm level tag represents our alarm state level. A value of 0 means it's idle or running. On this alarm level tag, we can now set the low, high, and high thresholds to represent the warning, urgent, critical states respectively. This is shown in the red colored boxes. The AC warning tag is, as mentioned before, configured to look at the high alarm, which is the urgent state. As soon as this is true, it will acknowledge the alarm group DI warning. You can name the alarm groups whatever you like, but I've chosen a naming convention that makes it unique for each alarm state so that we can use this acknowledge feature. Let's see how we implement this in OAS. Here I've got the OAS configure application open on the configure tag screen. I've created a digital input tag, which is a Boolean data type with a data source of value, so we can manually adjust it, but normally you would have this connected to some kind of data source. Here I've enabled the time on and counts feature in seconds so that OAS will track the amount of seconds that this input has been on for. In the level, we can now configure a calculation which looks at this value time on parameter of the digital input. So if this digital input is true and this time has been on for more than 30 seconds, that's a critical alarm. If it's more than 20 seconds, then that's the urgent level. And if it's more than 10 seconds, it's the warning. Otherwise, it's just 0, which is idle or running. In addition, we've now configured the low threshold, which is the -1 state, with a warning and a group DI warning. I've set this to priority 100. Then we've got the high threshold, which is at a value of 1, enabled, urgent alarm text, and a group of DI urgent with a priority of 10. Finally, we have the high threshold, which is the critical alarm, with critical alarm text with a value of 2, priority 1, and a DI critical group. So these are our 3 alarms. And then we have the acknowledgement. As mentioned, the warning alarm will not clear because when a lower level alarm is active, a high level and a high level will not clear the low level. So what we're going to do is, when that alarm level has a high alarm active, this value of the ACK warning tag will go true because the data source is set to this tag. And down here we've enabled the acknowledge alarms feature, and we've added the DI warning group. So what will happen is, when the high alarm is active, which is the urgent group, this tag will go true and it will trigger an acknowledgement on any alarm that has the DI warning group, which represents our low alarm. Now, I mentioned that a high alarm can't clear a low alarm, but a high alarm can actually clear a high alarm. But to make this work, we need to go to configure options, and then under the alarms tab, we need to make sure we tick clear high and low alarms when high and low occurs. So this will ensure that when the urgent alarm occurs and then the critical alarm, that will actually clear the urgent alarm. We can now test this using the OIS Trends and Alarms application. So if I put this over here, we can trigger the DI input to be true, and after 10 seconds this should trigger the first alarm level. We can monitor the alarm level here. At the moment it's still 0. Okay, so now the alarm level is -1, which is the warning alarm here on the right hand side. Now the next level should be 1, and it should clear the warning. There we go. So now you can see the text has changed to urgent, and the group is now urgent, and it's a high alarm type. And the next level will be the critical alarm, which is the high alarm, and there we go. It's now the critical alarm. So if I reset this back to false, the critical alarm will stay, but it's not active anymore. So we can double click to acknowledge it. And similarly, if I set this to true again, you'll see a new warning. If I now set this to false, the alarm will clear and remain at the last level. There we go. So that's solution number 1. The second solution will use a tag to represent each alarm state level, and this means we can set the digital alarm threshold and each delay on each of these tags. We need to make sure that if a higher level alarm occurs, the previous level is cleared. This can be achieved using a calculation, so that, for example, a warning alarm cannot be active if an urgent alarm is already active, and an urgent alarm cannot be active if a critical alarm is active. However, this doesn't solve the issue of automatically acknowledging an alarm. To do this, we need to create an additional set of tags responsible for the acknowledgement at each level, except for the last level, similar to what we did in solution 1. This solution uses more tags, but it clearly defines each alarm state as independent tags that are then daisy-chained to create as many levels as you need. Let's visualize this solution. Here we have the digital input called DI and one tag for each alarm level. The warning alarm logic is shown here, and the urgent alarm logic is shown here. You can see that a warning alarm can only be active if the digital input is true and if neither the urgent nor critical levels are set. Similarly, the urgent alarm can only be active if the digital input is true and the critical alarm is not active. This handles the automatic clearing of alarms. The ACK warning and ACK urgent tags on the right-hand side use the acknowledge alarms feature to handle the automatic acknowledgement. If an urgent alarm is active, then the warning alarm will be acknowledged. If the critical alarm is active, then the urgent alarm will be acknowledged. Let's see how we can configure this in OAS. Here I'm in the OAS configure application again, and I'm going to open solution number 2. As before, I've configured the digital input. This time I don't need to configure anything else other than setting it to a Boolean type, because we're not going to use the time on and counts feature. Now in solution 2 we've got every alarm level as an independent tag. So I've got here a warning alarm, which has the calculation DI value and not urgent alarm, digital alarm active, and not critical alarm, digital alarm active. So in other words, warning alarm can only be active if the digital input is true and there's no urgent or critical alarm. And here we've set the digital alarm threshold. The digital limit is true, so alarm when that is true, and the warning text priority 100 group warning. And now we've set the delay here as 10 seconds. The next level is the urgent level, similar thing. This will only be true if the digital input is true and it's not a critical alarm, and the digital threshold is configured as an urgent with a 20-second delay. And the final one is the critical alarm, which we don't need to use a calculation tag for this one because this is the final state and it simply depends only on whether the digital input is true. It doesn't look at any other alarms to make sure that this is cleared or anything. So this one just has a tag data source and it looks at the DI value. This is a critical alarm message with a critical group, priority 1, and 30 seconds. So this handles the clearing of the alarms using the calculations. Now we just needed the extra 2 tags, one for the warning to clear the warning. So we're using the acknowledge alarms feature again down here to clear the warning group when the urgent alarm digital alarm active state is true. Similarly, for the urgent, we will clear the urgent alarm if the critical alarm digital alarm active is state. So if a critical alarm occurs, the urgent will be cleared. We can now test this. I'm going to bring up the trends and alarm screen again and set the digital input here to true. You'll note that the values of the urgent alarm tags are true already. That's because of the formula, but the alarms won't happen until the timeout expires. Now that the warning alarm has happened, the acknowledge warning will come in once the urgent is set. There we go. And then again, once the critical alarm comes in, this acknowledge urgent trigger will come into play. There we go. Now we can set this back to false. And the alarm is cleared. Now we can acknowledge by double clicking. So you can see that's working fine. Now let's have a look at the history. So what we first need to do is we can go to the history and put in the date query for today. But we won't see anything because by default the filters actually don't show the alarm not active act state. So we'll turn that on and then do that again. Okay, now we can see the alarms from the solution 1, which was the warning low, high, high, high. And then we tested the warning again briefly, so that's why there's a second warning there. So you can see the solution 1 output will set the alarm type to high, low, high, high. Whereas solution 2, which is these top three, they used the digital state. So there was one warning, then the urgent, then the critical. Now you can see as well, OIS automatically acknowledged all the previous alarms except the one that we then double clicked on, and also it cleared the active state on all of them as it escalated, and then the last one cleared, which is the critical, once the digital input went back to false. To summarize, in this video we looked at how we can achieve alarm escalation over time. We covered two different solutions. The first used the time on and counts feature to create a calculated alarm level with the alarm delays included in the calculation. To create the alarms, the low, high, and high set points were configured. In the second solution, we created separate tags by chaining together the alarm active states and using the digital alarm thresholds with the delays configured in each tag. Both solutions used the acknowledge alarms feature to acknowledge alarms and ensure only the current state is shown on the alarm screen. We summarized the OIS alarm logging and notification features and looked at how we can quickly configure an alarm logging group to log alarms to a database and then view the alarm's history. You will find further information in the knowledge base on the OIS website. Thank you for your time.